Hello.
Hi.
Hi, Lux. How are you?
Good. How are you?
I'm also good. You did some test paper?
I did the test paper 9 and I got a 660.
Okay, let's check out the wrong answers.
And it was because of the no calculator portion, because in the calculator portion, I only got 5 wrong.
All right. Otherwise, calculator portion seems to be a little bit difficult, but let us see what was the thing here, like which was.
Okay. So in the no calculator portion, I got, which ones did I get wrong? 6. I didn't really understand 6. I tried to use the formula that we always use, but I don't really know how to use it.
Okay. So let's try to do 6 first.
So in 6, I did x over 360 is equal to 5p.
5 pi, right?
Yeah, sorry, 5 pi.
Yeah, but the thing is x over 360 times 2 pi r is equal to 5 pi. See,
oh, right.
isn't it? Because the length of the arc is x over 360 times 2 pi r. And they are telling you that it is equal to 5 pi, right?
Yeah.
So, and they're telling you that x is 100, right?
Yep.
Okay. So how much will be?
So does that mean that x over 360 is equal to 100?
No, x is 100. They are telling you x is 100, right? X is 100. So
yeah. Oh, okay. That angle I see.
yeah, that angle is 100. So 100 over 360 times 2 pi r equals 5 pi, right?
Yeah.
Or you can say 2 pi r equals, and you'll be simplifying it, it'll be like 10 over 36 or 5 over 18, right?
Yeah.
And when you'll multiply 18 over 5 to both sides, you'll be getting 18 over 5 times 5 pi. On the right side, 5 and 5 will cancel out. You'll be getting 2 pi r equals 18 pi.
Yeah.
Is that clear till now?
Yeah.
Since we don't want to calculate r, we can divide by pi to both sides, and pi will cancel out, pi and pi will cancel out. We can divide by 2 to both sides, so we'll be getting r as 9, right?
Yeah.
And then we can calculate length of the arc ABC. Length of the arc ABC. Again, the same formula. Since this is 100, how much will be this?
260.
Right. Again, same thing, same formula. 260 over 360 times 2 pi r. That is the length of the arc of ABC. So 26 over 36 times 2 pi times r is 9.
9.
And then 2 times 13, 2 times 18, and then 9 times 1, 9 times 2, 2 and 2 will cancel out, 13 pi.
Okay, yeah, that's the right answer.
So we use the formula, we calculate the r, and then we plug in the r in that formula which is needed in the question, the length of the arc ABC.
Yeah.
Is that okay?
Yeah.
So can you quickly tell me what we did here?
Yeah, so we used the x, which was 100, and we put it in the formula of the arc. And then we divided by 5. And then we divided by pi, so we could do like all the pi's would delete out. And then we divided the 18 by 2 to get 9. And then we substituted the 9 into the formula here to solve the rest, the other section of the arc.
All right. See, I'll tell you one more way of doing it. since you know that this is a circle and this angle is 100 degrees and 100 degrees corresponds to 5 pi, right?
Yeah.
And 260 degrees correspond to, we don't know, right?
Yeah.
We can make a proportion. 100 degrees correspond to 5 pi. That is equal to 260 degrees correspond to
Oh,
x, correspond to
X.
anything or y or whatever. And then you can, you know, simplify this thing. You can cross multiply, you'll be getting 100y equals 260 times 5 pi, dividing by 100, you'll be getting y equals 0 and 0, 5 times 1, 5 times 2, 2 times 1, 2 times 13, 13 pi again.
Yep.
So that's the answer. You can make a proportion or you
Yeah,
can
that's
solve it.
easier.
That was easier because we know that the length of the arc is dependent on the angle which it subtends in the center. The more the angle, the more will be the length of the arc. So that's why we
Okay.
can make a direct proportionality. And in direct proportionality, we divide, isn't it?
Yeah.
So that's what I did here.
Yeah, that's easy. Okay.
Next one.
The next one. See, 9.
Okay. Okay, we're having a parabola, we're having 2 lines. So we're having in total of 3 lines. And do you remember when we're having systems of equations of 2 lines and we were told what is the solution? Solution was the point where they're intersecting.
Oh, I thought solutions was how many times they pass through the X intercept.
That is only for when you're having any graph which is not having any other graph with it, you know, because it's independent.
Oh, okay. Well, then it's 2.
I don't know, like we have to calculate the solution of the system. So, well, we're having 3 things. At how many points these 3 graphs are intersecting? Like at how many points, you know, same point.
3.
No, I mean to say, we should have a point where both the lines are also intersecting and the parabola
Yes.
is also intersecting.
Yes.
So how many points are like that? Where both
Only
the lines
one.
are only one. So that's only one answer.
Oh, okay.
Isn't it?
Yeah.
So in the same way, you're having a parabola and you're having line cutting it. So there'll be 2 solutions if the line is cut. Because there's only one line. But if you're having one more line in the systems of equations like this, and it's cutting at only one point, all the 3 things are meeting at only one point, then we're having only one solution to all these 3 things.
Okay.
Right? So that is how you can think of, because here they have said that you're having 3 equations. One is a parabola and the 2 lines. So how many points are those points where all the 3 are meeting? It's only one point, and that's here, right? Otherwise, if you will take it independently, then the solution will be the x-intercepts, obviously, if you'll take it independently. But you are taking system, so you have to check out which one is common to all the 3. There's only one, and that's the answer.
Okay.
Next one.
Next one is 10.
Okay. All right, so
I substituted a number for X.
Okay.
And solved it, and I got 8 minus B is equal to 9, but I didn't know what to do with A minus B is like how to solve 9, not 8.
Sorry, then you had see, you're having 2 variables here now, A and B.
Yeah.
Then what you need to do is you need to plug in one more value for X so that you can get one more equation, right?
Oh, okay.
Because you're having, you don't have only one variable here. You don't have only one unknown here. You're having 2 unknowns. So in order to make, when you'll be plugging, you plugged in X as 1 or what?
Yeah, X is 1.
Now you can plug in X as -1 or 0 or whatever, you know, and then you'll be getting one more equation. So, and then you can solve those 2 equations to get the value of A and B, because 2 equations are needed for solving 2 unknowns, right? That is the way. But the thing is, it's more simpler if you will compare the things on the left and the right. As I told you, if you're having ax squared plus bx plus c equals 2x squared plus 3x plus 4, can't you like, don't you compare the things? A is 2, B is 3, C is 4. So when you're having ax squared plus bx plus c equals 2x squared plus 3x plus 4, don't you compare the things? The coefficient of x squared is a, the coefficient of x squared is 2. So we
Oh,
can say that.
yes.
So we'll do the same thing here. It's a cubic equation, so we'll be having the same principle, but we'll be multiplying this thing first. Ax times 5x squared, ax times negative bx, ax times 4. How much is that?
5ax squared.
X cubed, sorry.
Oh, yeah.
And then
minus abx squared.
And then
4ax.
okay. And then you had to multiply 3 with all these 3 terms.
Yeah.
So how much is that?
So 15x squared minus 3bx plus 12.
All right. So any term having the same variable and the power on the variable?
No.
1 second. 5ax cube is, there's no x cube term there. So I can write 5x cube again here. But you're having x squared terms, you're having here too. Here, see?
Oh, so it's 15 abx squared.
But it's in, it's in addition or subtraction. So you'll be writing it plus 15 minus ab x squared, right? And then anything related with x?
4ax, no.
Plus 4a minus 3b times x, see?
Oh, okay.
And then plus 12, right?
Yeah.
This is equal to 20x cubed minus 9x squared minus 2x plus 12. So x cubed is having a coefficient of 20 and x cubed is having a coefficient of 5a. So what does that mean?
A is equal to 4.
Very good. So a is equal to 4. And 15 minus ab is equal to what?
15 minus ab is equal to minus 9.
Right. So 15 minus a times b is equal to minus 9. Subtracting 15. Subtracting 15 to both sides, we'll be getting a is 4, so we'll be getting minus 4b equals minus 24. Am I right?
Yeah.
So b is equal to?
Minus 24 divided by 4, which is 6.
Positive 6, because it's negative 24 divided by negative 4. So we got a, you got b. What is the value of ab?
4 times 6, 24.
That's the answer.
Okay. And then the next one,
or else you can, you're having AB here, so you don't need to even calculate A. Subtracting 15 to both sides, you'll be getting negative AB equals negative 24. That means AB is 24 something.
Yeah.
So that can also be done. Directly comparing the things. Next one.
11.
Okay. So I told you we need to plug in the things.
I did that and I got it wrong. I said it was only 4. So it was D.
Only 4, D, right?
Because 0 doesn't work. What was the right option? I don't remember.
I think D should be the right option, because if you plug in 0, it'll be 0 divided by 0 minus 3 equals 0 divided by 2. So it'll be like 0 equals 0. Oh yeah, 0 is working, right? Because 0 divided by negative 3 is 0, and 0 divided by 2 is 0.
Oh, yeah. Okay.
So 0 and 4. Right?
Yeah.
Because 4 divided by 4 minus 3 equals 2 times 4 is 8 divided by 2. So 4 divided by 1 equals 4. So 4 is equal to 4. So 4 is also working. 0 is also working. So 0 and 4 are the answers.
I just thought because they had different denominators that they were different.
When you'll be plugging in, we don't care whatever the denominator is.
No, I plugged it in, but like when it was 0 over -3 and 0 over 2, I thought that wasn't the same.
Okay, 0 divided by anything is 0. Okay, it's just 2 times 0 is 0. So 0 divided by 2 is again 0. No? 0 divided by anything is always 0. But 0 divided by 0 is indeterminate.
Okay.
Or undefined, right? So you should not be having 0 in the denominator. But 0 divided by any number, anything is always 0.
Okay.
Okay, next one.
Next one, 13.
Okay, so you're having a parabola here, and you're given the points and the vertex. That's telling you which of the following is the equation of the parabola, right? Isn't it?
Uh-huh.
Which of the following defines f? So simply we have to calculate the the equation of the parabola, or even we can check it. See, 2, 5 is on the parabola. Plug in 2 and 5. Whether that's working or not. 4, 5 is on the parabola. 3, 1 is on the parabola. So we can plug in any two numbers and check out which parabola is working. Like which parabola is giving you, left side equal to the right side, as we are doing for the other equations.
Yeah. Okay, so 4. So 4 times, y. So
yeah, y.
5 is equal to 4 times 2 minus 3 squared plus 1. 5 is equal to 4 times -1 squared plus 1. -1 square is 1. So 5 is equal to 4 plus 1. Yeah, the first one.
Yeah, but only one point is working. We can have one more parabola like this. We have to check out 2 points, I think, at minimum.
Okay, so 5 is equal to 4 times 4 minus 3 squared plus 1. 5 is equal to 1 squared, 4 plus 1. Yeah, it works.
It works. Okay, so it's working A, but I'll be still, do you know the vertex form of the parabola?
Is that the one that's like y is equal to 4a x minus, yeah.
But you have to remember this thing, because this is, you have to sometimes convert the equation into the vertex form. So at that time, how can you convert if you don't remember the standard, the form of it? So it'll be a times x minus h whole squared plus k, where h comma k are the coordinates of the vertex. So it'll be like y equals a times x minus h is 3 squared plus k is 1. So a can be 4, it can be whatever. So it's also matching option A and option C, right?
Yeah.
But we have eliminated option C because we have already checked out 2 points which are both working for option A. So option A is the right answer. You can check out, is that the right answer?
Yeah.
That's it. So why to like make the things complex? We have to just plug in the value and check out whether that's working or not.
Okay. And then 14. Also, I have to leave 10 minutes early today.
Oh, okay. Okay, so
I don't know how to do this at all.
All right. See, when you'll be making a line, y equals x plus 2, y equals x plus 2. What is the slope of this line?
1.
And what is the y-intercept?
2.
So we'll be starting at 2, and we'll be having slope is 1. 1 means rise over run is 1 over 1, isn't it?
Yeah.
So rise over run is 1 over 1, 1 over 1, 1 over 1, and so on. So we'll be making a line starting at 2 like this. Is that okay?
Yeah.
But this is not y equals x plus 2. It is y is greater than or equal to x plus 2. So that means it is all the values above that.
Okay.
And including that line, because that is also equal to. So this
So
is
then would it be option C? Because that's like,
but the thing is, like, you don't have the option, you don't have second equation in the y-intercept form, slope-intercept form. You have to convert that into
Yeah.
slope-intercept form first.
okay, y is
Mhm.
equal to negative 2x plus 6 divided by 3. So this is, okay, so it's negative 2/3 of x plus 3.
6 divided by 3 is 2, right?
Oh, 2, my bad, yeah.
Yeah. So that means, again, the y-intercept is 2. So we'll be putting y-intercept as 2 here. And then the slope is negative 2/3. So rise over run is negative 2/3. So you're going down 2 and 3
Oh.
like this, and down 2 and 3 like this, right?
Yeah,
So you can join the line like this. But this is y is less than or equal to, that means it's towards this side, right? It's below that line. Are you understanding why?
I see, yes.
So which portion is overlapping in the two?
B.
Which one? B. Right. That is the answer.
Okay,
So that is a way of doing it. And
yeah,
so
I got it.
making the line and then checking out whether that is greater than or equal to or less than or equal to. If that is greater than or equal to, then it's above it. If it's less than, then it's below it. And then checking out which portion is overlapping. So that is the solution.
Okay.
Next one.
18 is the last one.
So you're having some graph here, and it's telling you the figure above shows the complete graph of a function in the xy plane. The function g, not shown, is defined by g of x is f of x plus 6. You remember when we're having a parabola y equals x squared, the simplest parabola, it was like this.
Yeah.
And when I told you that if you have to shift it to up or down, then you have to simply add or subtract. For example, x squared plus, then you'll be shifting it to 5 units up.
Yeah.
And if you want to shift it down, then it'll be subtracting, that number. So it'll be shifting it down. So what's happening here?
It's like repeating. Oh, it's adding 6.
So adding 6 means what? What are you doing to this graph?
Moving it up 6.
Moving it up 6 units. So if it's at 2, if this point is at 2, you're shifting it 6 units up. So where it'll be?
At 8.
At 8, exactly. So it'll be at 8, like this. Now the question is, what is the maximum value of the function g? So what's the maximum value?
8.
That's it.
Oh.
Yeah, because you have to understand what happens to the graph when you're adding a number, subtracting a number, But if this question would have been g of x equals f of x minus 2 plus f of x minus 2. So what are you doing there now? Are you shifting it up or down?
Moving it down too.
No, moving it down means adding, to the function, not to the internal x.
Oh, sorry, moving it to the right.
Right, correct. Moving it right. But the maximum value will still be 2, but still you're moving it to the right. And if it have been x plus 2,
moving it to the left.
Correct. And if it have been f of x plus 2 minus 7,
moving it down 7, or to the left 2 and down 7.
Left 2 and down 7, correct. And that is how you can understand what's happening to the graph.
Okay.
So this was no calculator portion, right?
Yeah.
Now let's move to the
calculator portion.
Are you having 1920?
Yeah, I had some wrong.
Okay.
10.
Okay. Okay, so there's a school, Washington High School randomly selected freshmen, sophomore, junior, and senior students for a survey about potential changes to next year's schedule. Of students selected for the survey, 1/4 were freshmen. All right, so So whatever the number we have selected for the survey, you know,
Yeah.
we have, for example, if that is X, 1/4 of X are freshmen, right?
Yeah.
1/3 of X are sophomores.
Yeah.
Half of the remaining selected. All right. Half of the remaining selected students were juniors. So now the problem is how much is now, you know, left. 1/4 of X and 1/3 of X. Oh, we are given 336. It's easier. So if 336 students were selected for the survey, then how many are freshmen?
336 divided by 4.
So what's that?
336 divided by 4. 84.
And how many are sophomores?
112.
So how much is the total?
196.
So 196 are selected, like they are freshmen and sophomores. Now how much is remaining out of 336?
140 divided by 2 is 70.
Right.
So 70 juniors.
70 are juniors. So how many were seniors? Okay. So
336 minus 226.
336, see 336 minus 196 is how much?
Yeah. 336 minus 196 is 140.
Minus 70.
Well, it's gonna be 70.
That's the answer.
Okay.
Why? Because the thing is, like, you're having 4 things here: freshmen, sophomores, juniors, and seniors, right?
Yeah.
And we know that the total is 336, correct?
Yeah.
Freshmen is 84, sophomores are 112, juniors are 70. How much is left?
Yeah. No, I don't know how I got that one wrong. It was easy.
Only trying to understand the thing, you know, makes the things
Yeah.
easier. Okay, next one.
15.
So we're having a line M in the xy plane containing the point 2,4. So any point there, 2,4 and 0,1. We can calculate everything from these 2 points. First of all, we can calculate the slope.
Yeah.
y2 minus y1 divided by x2 minus x1. How much is that?
So 4 minus 1 over 2 minus 0, that's 3 over 2.
So slope is 3 over 2. Eliminate A, eliminate B. So C and D can be the answer. Now.
Yeah. Oh, and then we can do the formula y minus y1 is equal to, so y1, what was y1? 1. Y minus 1 is equal to 3x minus 0.
But you have to calculate the y-intercept, so you'll be using the slope-intercept form. Y equals mx plus b.
Yeah, but if you use this formula, like y minus y1 is equal to
M times
slope.
x minus x1.
Yeah, it gives it to you.
But, oh yeah, that's right. You can use this thing also. Correct. Y minus
3x. Oh, 3.5. Plus 1.
Okay, what is y1?
1.
Okay, y
minus 1 minus, or yeah.
Yeah,
like
y minus y1. So y1 is 1. So y minus 1 equals
y is equal to
3.5.
3/2.
X minus
0.
0. Right. So we can simplify this thing. So it'll be like y minus 1 equals 3.5x, because you're having 0. X minus 0 is x, right?
Yeah.
Now, what you can do here is you can add 1 to both sides.
Yeah. Exactly. 3.5x plus 1.
So which option?
D.
Right. Done.
Yeah.
So what is the confusion here?
Yeah, I don't know. Oh, that was stupid. And then 24.
All right. Okay, so we're having the function f of x equals this thing and f of x plus a is this thing. So what's the value of a? Well, we know that f of x is 5x squared minus 3. And if you want to calculate f of 2, what do you do?
Substitute.
Yeah, substitute the value of x is 2 times 2 squared minus 3. Now, if you want to calculate f of x plus a, what do? Substitute the value of
x plus a.
Right, so instead of x, you'll be writing x plus a squared minus 3, right?
Yeah.
And that is equal to, they are telling you that f of x plus a is equal to 5x squared plus 30x plus 42. Is that right?
Yeah.
Now I can simplify this thing. 5 times, it is x plus y whole squared. It's the formula. It's the identity.
Yeah.
How much should I write here?
X plus a.
X plus y whole squared is equal to x minus y whole squared is equal to x squared minus y squared is equal to 3 identities which I have told you.
Oh, yes. Okay. X squared plus 2xy plus ax plus y squared.
Exactly. So we'll be doing the same thing here. So x squared plus 2xy, 2xa plus y squared plus a squared, right?
Yeah.
Minus 3. Now multiplying by 5. So 5x squared.
5x squared plus 10x.
10xa or 10ax plus a squared minus 3 equals 5x squared plus 30x plus 42, correct?
Isn't it 5 times a squared?
Oh yeah, sorry, it's 5 times a squared. You're right. You are absolutely right. So 10ax is how much equal to?
30.
So 10a is 30. How much is a?
3.
That's it. And the constant is this whole thing. How much that is equal to?
5a squared minus 3. 5 times 3, 15. 15 squared. Let me check.
Whatever that is, I was just comparing the thing here. 42.
Yeah.
Right?
Yeah.
Because we're having the constants. We don't need to solve this second equation, but if the first equation would not give us the answer, then we can use this equation to solve for a. But we already got a as 3. That's option C.
Okay.
Is that clear? Again, comparing the things, nothing else.
Yeah.
Not a big deal, isn't it?
No.
So how can you make the things better? Because you know how to solve it.
Yeah.
So next one, anything else?
36 is the last one.
Okay, so 2 equations there are, and they're telling you the systems of equations, it has no solution. So no solutions means what?
I don't know. I don't know what that meant.
If you're having 2 lines.
Oh, then they never pass a 0.
That is, they never pass each other. They never cross each other.
Oh yeah, so they're parallel?
They are parallel, exactly. If they are parallel, then they are having no solution.
Okay.
And for being a parallel, slope should be? Slopes of the 2 should be same. Simple. So we can check out the slopes of these 2 lines and equate them. That's it. Let's try to write them in slope intercept form.
Yeah.
So can you tell me how should I write it?
Wait, so y is equal to -3/4 of x plus 12, and then I multiply it by 2?
Yes, -2.
Oh, okay. So -3/4 times -2 is 6/4. So y is equal to 6 4s and 12 plus 24.
It's -2 times 12. It's -24, right?
Yes, -24, right?
6/4 can be simplified as 3/2, right?
Yeah.
So y equals 3/2x minus 24. So what's the slope? What's the slope for
3/2.
3/2? Correct. Now, can you check out the slope of the second line?
Well, yeah, so y is equal to ax over 9 plus 9 divided by -b.
Okay, so y equals -a divided by -bx plus or minus 9 over -b, right?
Yeah,
Oh, sorry, not minus 9 over b, right? So what's the slope here?
a over b.
A over
Negative
b.
a over b.
Negative is positive, right?
Oh, positive.
So a over b is the slope, and that should be equal to the slope of the 3/2, right?
So 3/2.
But a over b, you got 3/2. You have to calculate. Oh, you have to calculate a over b, and that's 3/2. That's it.
Yeah.
Done.
Okay.
So whenever you're having, two equations, and you have to check out, any constant, any number, any variable which is, which makes the things no solution, then you can say that if you want a no solution, then the slope should be same, and you'll be comparing the slopes, and the y-intercept should be different, right? Y-intercept should be different. Slope should be same. Because if slopes are same and y-intercept is also same, then you'll be having infinitely many solutions. They are on each other. If the slope is same, y-intercept is same, then these lines are overlapping. They are on each other.
Yeah.
Isn't it? And if you're having one solution, then
they're perpendicular.
No, not perpendicular. They can be anything, any angle. If they're having one
right.
solution, they are having different slopes. Then only they will be
Yeah.
They'll be having different slopes. Whatever the y-intercept is, that can be same, that can be different. But for getting one solution, the slope should be different. Exactly.
Okay.
And even you can do this thing for a parabola and a line also. If you want to see that parabola and line should not be having any solution, then then you have to accordingly say that set up the equations of the variables that they should not be cutting each other, touching each other. And if they are just touching it, then touching it at one point, you'll be having one solution. Cutting at 2 points, then you'll be having two solutions.
Yeah.
All right, so this was 36 equations, systems of equations. And quickly, can you tell me if you're having 2x squared minus 3x plus 7 equals 0, what is the sum of the roots? Directly. Oh, it's getting out. It's taking us out. Can we log in again?
Yeah.